Right. Air is pumped into a spherical balloon. What's going to happen when air is pumped into a spherical balloon? It'll increase in size. Its volume will get bigger. So three things increase. The radius increases, the surface area of the outside of the balloon increases, and the volume increases. They all increase. They increase at different rates, but they're all getting bigger. Right? Air is pumped into a spherical balloon at a rate of 300 centimeters cubed per second. Now, 300 centimeters cubed is a what? 300 centimeters cubed. That's a measurement of what? Volume. So that's dV dt. That's the rate of change of volume with respect to time. So what are they telling me? You know dV dt. Yes? The rate of change of volume. When the radius of the balloon is 15 centimeters, I'm asked to find the rate at which the radius is increasing. They've asked me to find out the RdT. I know the RdT is the Rd something by d something dt. Do you understand that? What's missing? dV. Because volume is worked out. Yes? Have you any questions? So that's equal to the RdT by dV dt is 300 centimeters cubed per second. What have I to work out to finish this? The RdV. I know that the volume is what? 4 over 3 pi r cubed. From that I could work out what? dV dr. What's dV dr? 4 pi r squared. Was I asked to get dV dr? What do I need? The RdV. So what would the RdV be? 1 over 4 pi r squared. Just the inverse. Yeah. So that's 1 over 4 pi r squared, which is 300 over 4 pi r squared centimeters per second. Now, what do I need to know in order to evaluate what it is? The radius. At r equal to 15, that's equal to 300 over 4 pi times 15 to be squared centimeters per second. I don't know what that is. It's 1 over 3 pi centimeters per second. And I could put that into a decimal if I so wish. Listen to this question. When the radius is 10, will the area of the surface be increasing as quick as when the radius is 15? No, the bigger the radius, what about the surface area? And the rate of change of the radius depends on what? What the radius is itself. Yeah? Good. And part 2, the rate at which the surface area is increasing. What am I asked for? dA dt. dA dt is dA d something by d something dt. Huh? Well, is it dA dr by dr dt or dA dV by dV dt? dr is correct because to get dA dV, the volume will be in terms of what? The radius. What will the area be? In terms of the radius. So that's equal to that by dr dt. 1 over 3 pi centimeters per second. Why is it that? Well, the radius, I'm asked to do it when the radius is 15. What's the area? The curved surface area of a sphere? 4 pi r squared. So therefore the dA/dt is equal to 8 pi. Is that alright? Sorry, dAd or 2 fours are 8 pi. So it's 8 pi times that, which is 8 over 3 centimeters squared per second. That's the rate at which it's increasing. I left out something there. That's 8 pi, or yes, when I differentiate that, the r was a squared, is 8 pi, or so it's 8 times 15 over 3, which is 3.5, is 14 centimeters squared per second. And I just have one question for you. I said it's the ADR by the RDT. I'd imagine some students may have written the ADV by dV dt, yes? Because they knew dV dt, but then they had to get the ADV. So they need to be able to write the volume in terms of A, or else the area in terms of the volume. And what was possible about that? It wasn't possible. The ADR by the RDT, it was easy to write the area in terms of the radius. So that's why I would have gone along that route. So each one of these is a what? A chain rule. And out of the chain rule, you're given one, and what do you have to do with the other one? Calculate. In other words, there'll be a formula, there'll be some way of getting the RDV or dVdr or whatever.